So here's the final type of factoring before we move on to factoring completely. It's extremely similar to type 3, where we just factored trinomials whose leading coefficient was equal to 1. Just like there, we're still going to have to look at our C term. But unlike the last lesson, the two numbers that you pick are not going to immediately add or subtract to the B term. You're going to have to multiply your outers and your inners and then combine those products to see if they add or subtract to the B term. It's going to require some guessing and checking or some trial and error. Don't be discouraged if you don't get the answer immediately. I suggest you work with a pencil. I am going to show you some tricks, but I am going to mess up a few times just so that you see it takes some trials before you succeed. So here's the first one. If you notice, as far as our standard form goes, our A value is not 1, it is 2. So this is going to change our procedure just slightly. We still need to look at our C value, but unlike the other day, the numbers that multiply to 3 are only 1 and 3, and if you notice, 1 and 3 will never add to 7. Now they won't add to 7, but the product of the outers and the inners will. So unlike x with x, now we're going to have a 2x with an x. And that's our only option because 2 is prime, so the only way to multiply to 2x squared is 2x and x. Now, if I put the 1 here and the 3 there, I then have to check my outers and my inners. So here I would have a 1 times an x, which is 1x, and 2x times 3, which is 6x. Now what I need to do is ask myself, will 1x and 6x ever combine to give me a 7x like I need in the middle? The answer to that is yes, if I add them. Now, in order for me to add them, their signs need to be the same. So let's look at our C value. Our C value is positive, which means our signs will be the same. So they will either be plus, plus, or minus, minus. We then look at our B term, and that is a positive, which means our factors both have a positive sign. Now, if you look, that would mean that 1x is a positive 1x, and 6x is a positive 6x, and when you add those two together, you will get that 7x you need. So I'm just going to double check this. 2x times x will give me 2x squared. My outer gave me that positive 6x. My inners give me the positive 1x, and the 1 times the 3 gives me a positive 3. When you add the middle two terms, they will combine to 7x, just like we needed at the start. If for some reason you put the 1 and the 3 in the opposite spot, I'm just going to show you. I honestly just took a guess and it worked. But say I put the 3 here instead and the 1 there instead. Well, if I did 3 times x, I would get 3x, and 2x times 1 is 2x. And 3x and 2x will not add to 7x. So then I would erase them and try them in their opposite spots to see if I get the 7x that I need. So again, please don't be discouraged if your first guess doesn't work out. The next one. Again, our leading coefficient is not equal to 1. So this is a little bit of a curveball. We make two sets of parentheses and we try to figure out, how do I get to 5x squared? Well, because 5 is prime, that would be just 5x and x. Now, just like always, we look at our C term. Our C term is 2. That's also nice because 2 only has the factors of 1 and 2. So if I put the 1 here and the 2 there, and I look at my inners, which is 1x, and my outers, which again, you're multiplying, so it's the product of the two, would be 10x. Will 1x and 10x ever add or subtract to 3x? The answer to that is no. So this trial did not work. Let me switch the 1 and the 2. I'll put the 2 here instead and the 1 there. Now that gives me 2x as the product of my inners and 5x as the product of my outers. Will 2x and 5x ever give me 3x? The answer is yes. I need to subtract them. Well, that does make sense because our C term is negative, which means signs are going to be different, which means the product is going to subtract to 3. Now we look here and we look that the sign of 3 is positive, which means either 2x or 5x need to be positive. It's always the bigger of the two. So because the bigger one is 5, 5 needs to be positive, which means 2 needs to be negative. And that's because signs need to be different. Well, in order for 2 to be negative, we can't change x, which means we'll have to put the negative in front of the 2. And for 5, we would put a 1 in front of the 1 to give us a product of 5x. When we check, we get 5x squared. The outer gives us positive 5x. Inner gives us negative 2x. And negative 2 times 1 is negative 2. When we add the middle two terms, we get that positive 3x that we need. Next one. Again, we don't have a 1 in front of the y squared, which makes this a little more tricky. We make 2 sets of parentheses, and we put in the first spot 2 numbers that multiply to 7y squared. Again, 7y squared is an odd number, a prime number, so the only way to get to it is 7y times y. 5 is also prime. There's only one option, 1 and 5. When the numbers are prime, it really decreases the number of trials because there's not many other options to try. So let's try putting the 5 here and the 1 there. Our inners would give me 1y and our outers would give me 35y. If I add the 2, I get 36. If I subtract the 2, I get 34. Neither one is what I need, which means let me try switching the 1 and the 5. I'll put the 5 here and the 1 there. Now 5 times y is 5y, and 7y times 1 is 7y. And now I think, oh my goodness, 5y and 7y will give me 12y if I add them. Now the only way to add them is if the signs are the same, and because C is positive, signs will be the same. We will look to see what the B term is. It is positive, so we give both of them a positive. Now let's just check. 7y times y is 7y squared. The outer product is 7y. The inner product is 5y. The last 2 terms multiplied give me a positive 5. The middle 2 terms, when added together, give me 12y, which is what I needed. Again, we try. If it doesn't work, we try again. This one's going to be a little bit trickier. The reason why is because 6, both here as the A value and here as the C value, are not prime. So when we make our first set of parentheses, we could either have a 1x with a 6x, or we can have a 2x with a 3x. So right off the bat, we already have 2 different possible combinations. Now, again, the way to get to 6 is 1 and 6 or 2 and 3. So let me give you a little bit of a hint. You're never going to put a number in a parenthesis if it will have something in common with it. So for example, let's try 1 and 6. I would not put the 6 here because now 6 would have something in common with 6. So instead, that limits me to put the 6 over here and the 1 over here next to it. So now when I check my outers and my inners, I get 36x and 1x, which will never give me the 5 I need in the middle. So that is over. Now let's try the 2 or we could try the 1 and the 6, but if you notice, if I put the 6 here, it has something in common with the 2, which means I would have to put the 6 here, which means it would have something in common with the 3. So I know it's not going to be 1 and 6, which means let's try 2 and 3. I would not put the 2 here because it has something in common with the 2, which means if I put it here, we're better off because it has nothing in common with the 3. And that would mean that the 3 would have to go here with the 2, which means there's no GCF. If there is nothing in common in the beginning between all 3 terms, there will be nothing in common at the end. Okay? So now let's look at the sign. The sign needs to be different, or the signs need to be different. So let's determine. We have 3 times 3x, which is 9x. And we have 2x times 2, which is 4x. And now 9 and 4 will give us that 5 we need in the middle if we subtract them. And yes, 9 and 4 will subtract to 5, but it has to subtract to a positive 5. So the sign of the bigger will be positive. Now the bigger value here between 9x and 4x is 9x. So that needs to be positive and 4x needs to be negative. Which means that if you look at what's connected here, this 3 will be positive, and with the connection here, this needs to be negative. So now let's check. 2x times 3x is 6x squared. The outer gave me negative 4x. The inner gave me positive 9x. And then we have minus 6. When we combine the middle 2 terms, we get the positive 5x that we needed from the start. So again, I went through a few trials here, and I gave you some hints as to what trial to not even try because it might not work. And most of the time, that's what happens. 2 more. We have 4x squared, which again is not prime. And then we have 2, which is prime. So that's actually not so bad. We'll make 2 sets of parentheses. And right off the bat, we're either going to have 4x and x in the front, or we're going to have 2x and 2x. Now the factors of 2 are 1 and 2. Hopefully you remember the hint of not putting the 2 here, because then it would have something in common with the 4. Which means I would put the 2 there. If I put 2 there, I'd have to put 1 there. Now, the product of 1 and x is 1x, and the product of 4x and 2x is 8x, and 1x and 8x will give me 7 if I subtract. Why do I need the 7? Because the b term is 7. So now I know that it's not this option, and I would only try that if I didn't have a choice. Signs have to be different. Bigger one gets the negative. So bigger is 8, which means 8 needs to be negative, so that means this 2 needs to be negative. 1 has to be the opposite sign because signs have to be different, so that will be positive. Now we check by distributing. 4x squared minus 8x plus 1x minus 2. When we combine the middle 2 terms, we get the negative 7x that we need. Last but not least, again, this might require a few trials because 6 is not prime, and unfortunately, neither is 10. So, for 6y squared, we have the options of 6y and y, or we have the options of 3y and 2y. For 10, we have 1 and 10, or 2 and 5. So let's start with 1 and 10. And I'm just starting because that's the one I wrote first. I would not put the 10 there because they are both even and they don't have anything in common from the start, so they won't have anything in common at the end. So instead I'd put the 10 here, which would limit me to the 1 there. When we multiply, we get 60y and 1y, and oh my goodness, that is not going to give me 19. So this trial has been exhausted. It doesn't work. Let's continue with the 3y and the 2y. Again, this is why I recommend pencil. Let's start with 1 and 10. I would not put the 10 here because it would have something in common with the 2, which limits me to putting it with the 3. That means the 1 would go here. 10 times 2y is 20y. 3y times y, 1, is 3y. And 20 and 3 either add to 23 or subtract to 17, which is not what we need in the middle. So 10 and 1 didn't work, but that doesn't mean that we still can't get this correct. Let's try the 2 and the 5. I would not put the 2 with the 2 because obviously they have something in common, which means I would put it instead with the 3, which means then the 5 here would go with the 2. 2 times 2y is 4y, and 3y times 5 is 15y, and yes, Those two will give me 19 if I add them. So let's look at our signs. This is a positive C term, which means our signs need to be the same, which means they're either plus plus or minus minus. We look at the B term, it's positive, which means they are both going to be positive. We'll check our answer. 3y times 2y is 6y squared. 3y times 5 gave us that 15y. 2 times 2y gave us the 4y, and 2 times 5 gave us 10. When we combine the middle two terms, we get the 19y that we need, which is exactly what we had to start. So these are a little more challenging. You need to pay attention. You need to try multiplying your outers by your inners and then adding them or subtracting them to get the B value that you need. Don't be discouraged if you do not get the answers right away. Try again. Try all possible combinations. Eventually you'll get better, just like anything else that you keep trying with.